Welcome back to Algebra with Miss Swartz. Today we're going to do an intro to point slope form. This won't be the last time we see this. We will spend a little bit of time tomorrow going over this. This video is your homework, so you're going to watch it and do the couple problems at the end, and then you're done with your homework. That's what we will go over tomorrow, as well as your homework from Monday over section 4.1. So today we're talking about a new form we can write linear equations in. So point slope form, and this is what you need to understand. To be able to write an equation, because this is what this chapter is about so far, is writing equations. In section 4.1, we talked about slope-intercept form. Well, we had already worked with slope-intercept form, so that should have been fairly simple. If you're not understanding slope-intercept form, please come talk to me. I want to help you out with that. But when we did that, we generally were given slope and intercept, m and b. Well, now we might not be given that. We can also make this work if we have an m and we have any point. So like 3, 1. Okay, if we have a slope and then an ordered pair. We can also make it work with 2 points, because then we can use one of the points like we would here, and we could figure out our slope. So that's what we're going to look at today. What is point slope form? So based on the name, it kind of gives you an idea, just like slope intercept form, what we're going to be seeing. We're going to use a point and we're going to use slope. So make sure to write this down. Okay. A linear equation written in the form y minus y1 equals m times x minus x1 is point slope form. So that might seem like a lot, but remember, we always have a y and we always have an x. Right now, all we've added to the situation is our slope, which we see on a regular basis, and then we have a point, x1 and y1. That's just our point. So the line passes through the point x1, y1, and the slope of the line is m. So our algebra here, this is what you got to know. Just like you know y equals mx plus b, this is just another way to help us be able to write equations. Y minus y1 equals m times x minus x1. Now the nice thing about this form right here is we can convert it to slope-intercept form, which makes a lot of sense to us because we've worked with it a ton. We can convert it very easily. So hopefully you have this written down. You don't need the picture necessarily, but just the words is good. Okay, so this is another one of those pieces you kind of want to memorize. So let's look. It says, write an equation in point slope form of a line that passes through the point -8, 3, and has a slope of 1, 4. So we're going to put it into the formula y minus y1 equals m times x minus x1. So what we have here, this is my slope, so that's going to be m, and then we have a point, so we have x1, y1. So now we're just going to plug them into those spots. Y and x are always going to stay the same, but we're going to have y minus 3 equals 1/4 times x minus -8, so we're going to change this to +8, because minus and negative is plus. There we go. This is point slope form. We're done. That's all we need to do. Now, we're going to get to a point where we may be asked to change this into slope-intercept form. We're going to talk about that when we get there. Okay. Next example then. So write an equation in point slope form of the line that passes through the given point and has the given slope. Same thing, same process here. So y minus y1 equals m times x minus x1. Remember, your x and y are what make this equation true that we're writing. Okay, they're an ordered pair that make the equation true. They're going to be on this line of the linear function. So we have y minus, well, our y1 is right here, so we're actually going to have +1 equals, our m is -2, x minus, our x1 is 3. So you can write it out if you need to. This is our m. I plugged it into those spots. So here is our point slope form. Same thing with this one. We're going to plug it into our spots. So we have y minus 0, so we can just leave it as y equals m times, oops, I don't need m, I need 2/3. I'm trying to write the equation here. 2/3, negative 2/3, times x minus 4. So I didn't write minus 0 because I didn't feel like I needed to write y minus 0. I know that's just y. Okay, next examples. Now we're going to get into, we have a graph and we want to figure out slope-intercept form. Now, it doesn't hit the y-axis here. It doesn't show us where it hits the y-axis. So we don't know our y-intercept right away. So what we're going to use is we're going to use point slope form to start, and then we're going to change it to slope-intercept form. So we're going to first write it in this form. Y minus y1 equals m times x minus x1. Well, you could pick either point. It does not matter. So if I pick this point as my x1, y1, that's great. Okay, so from there, I can plug that in. I'm going to have to figure out my slope, so I'm going to wait for that. Okay, so now my slope, it's going down from left to right. It's going to be negative. So I'm going to count down 1, 2, 3, 4, and over 2 to the right. So that's positive. So down 4 is negative 4 over 2, which would be negative 2. Okay, so now I want to change this to slope-intercept form. Well, to be in slope-intercept form, I have to be in y equals mx plus b. Okay, so I need y by itself. That would be our key here. So to get y by itself, I'm going to have to subtract 2, but to subtract 2, I need a little bit more clear over here, or simplified over here. So I'm going to distribute my negative 2. So I get negative 2x plus 2, because a negative times a negative is a positive. Now I can add 2 to both sides. So y is going to equal negative 2x plus 4. Are we in slope-intercept form? Does that look like that? Yes, it does. So to change point-slope form to slope-intercept form, we're going to distribute and then get y alone. Let's try another example of that. Okay, so we did this a little bit with slope-intercept form where we had, it gave us the slope and it gave us the these points, okay? Well, here's the thing. These points that we have, okay, it's telling us in the function if we plugged in 4, we would get negative 2. So essentially we have 4, negative 2 as a point. And here we have 8, 4. If we plugged in 8, we would get 4. So now we have 2 points. Remember, for us to be able to work with this, we need the slope. And this time it did not give us our y-intercept. So we got to start with point-slope form. So first I'm going to figure out my slope. So I got y2 minus y1 over x2 minus x1. Okay, hopefully we're getting better at this. We're going to do x1, y1, x2, y2. So we get 4 minus negative 2 over 8 minus 4. So we're going to add, we got 6 over 4, or 3/2 is our slope. Okay, so that's m. Now, if I want to write it in point-slope form, this is my y1, x1, y1, so I'm going to use that to write point-slope form. Y minus, or plus 2, because it's a negative 2, equals, my slope is 3/2, and then x minus 4. All right, so now to change this to slope-intercept form, which is what we wanted in, okay, want that linear function in slope-intercept form, I'm going to distribute my slope. Okay, we get 3/2 x, and then If I multiply by negative 4, I get negative 12 over 2. Think about it like this. Okay, so I get negative 6. 12 over 2 is 6. Now I'm going to subtract 2 from both sides. So we get y is equal to 3/2 x minus 8. And this would be our slope-intercept form. So again, we just multiplied our slope by both pieces inside the parentheses. We distribute that, and then we get y alone, however that looks. Okay? So these are your homework problems. These are what we're going to have you try. Again, we're going to go over more of this tomorrow. I know this is your first exposure to point slope form. So I want you to try these 3. With 3 and 4, you're going to have to find the slope using y2 minus y1 over x2 minus x1. Okay? And then you are going to have to put it in point slope form. Y minus y1 equals m times x minus x1. And then you're going to have to change it to slope-intercept form. I realize that's a lot. Okay, with 5, you're going to use your points here. If we plug in 2 to the function, we get 3. And if we plug in 6 to the function, we get 5. Okay, so for all of these, you're going to have to use both pieces here. All right, have a wonderful night. See you tomorrow.